I'm Andreas. I work at WhatsApp in the developer infrastructure team. And one of the missions of the team is to make developing the services that power WhatsApp as, let's say, pleasant as possible. And most of our services, or the vast majority of our services, or the code that we use to develop is written in Erlang. So naturally, we develop a lot of Erlang tooling, and when we have a good milestone, or we build a tool that we can open source, and luckily we can do that as well and give it back to the community so that other people might be able to use it as well. But let's talk about building Erlang with Buck2. So one might ask, why do we need another build system? And for us, the reason is really that well, we are foremost building tooling for our own needs. And our code base is really large. So we have thousands of Erlang files, we have millions of lines of code, we have to build our releases, we have to build our containers for deployment, we have e-scripts, we have supporting infrastructure, and so on and so on. And all of this is in a single mono-repository. Historically, we have actually been using other build systems that are quite well known in the community as well. We have started with Make. A couple of years back, we migrated everything to Rebirth 3, and now we migrated the entire build process to Buck2. And we have experienced different problems using those build systems, right? So our Make system was mostly custom. It was hard to maintain and expand. It was particularly hard to handle dependency for applications and releases and so on. And then we said, Rebirth, it's amazing. We get all of this for free. It's easy to handle for dependencies. It essentially does it for you for free. There are lots of integrations for free, like Dialyzer, Xref, Common Test integration, all of this kind of stuff. And there's some way of extending it through this plug-in system. You can add more providers, you can modify existing providers, and so on and so on. But really what we noticed after a while is that we tended to deal a lot with scalability issues that come from working with Rebirth 3. Ultimately, it's a build tool for small projects, and it doesn't really scale well if you have hundreds of applications. There's a poor incrementality for non-build workflows. So while building is, let's say, it's okay optimized, everything else is really not. And if you make small changes and you have to run a non-build workflow, you have to just do everything again. And the way how Rebirth suggests you organize your ways in one gigantic umbrella project if you have everything in one repository, because otherwise you cannot really depend on code to each other cleanly. And there's essentially, I wrote poor modularity. There's really zero modularity within an umbrella project. It's just essentially one big build blob that you have to do or not. So we really ended up with a tons of custom plugins, not just to interface with our other systems, but also to kind of mitigate the scalability issues that we have with Rebirth 3. And then all the advantages that you use a standard build tool, they just suddenly go away because you have to maintain a lot of the stuff yourself anyways. And I just want to, this is like an exclamation mark here. I'm quite aware this is let's say, large company projects. If you have not everybody has a large code base. Rebirth mostly works fine for smaller projects with a limited set of dependencies, which most open source projects tend to be. Okay. So what is Buck2? Buck2 is Meta's new build system for large-scale builds. It's the successor to Buck. That's why it's called Buck2. And in its current form, it comes with a standard library that includes build rules for C, C++, for Python, for Rust, and for Erlang. It's open sourced. You can use it right now. It's available from buck2.build. There are open source repositories linked. There's a lot of documentation. If you're interested in using something like this, I encourage you to go there and read up. And when you look a bit into documentation, so the evolution of Buck2 is essentially, it's a rewrite of Buck1, trying to get to solve the problems that we had with Buck1, like making it more scalable, while keeping a high level of compatibility. But it also takes a lot of ideas from academic research and other build systems like Bazel, Pants, and Shake, and so on. It's written in Rust. It's essentially just one static binary that you can deploy. There are not much other dependencies that you need. And it's built with remote execution in mind first. So remote execution is essentially you pack the inputs of your build job, you send it to the cloud or to a worker. It executes this build process, you download the results, the artifacts. And because it's written with remote execution first in mind, it kind of forces you to write and structure your rules in a more restrictive way, but also allows for optimizations that otherwise wouldn't be so easily possible. All the rules are written in Starlark. They're entirely separated from the build tool. I like to use the comparison with Make. Buck2 is the tool. It's entirely language agnostic. And the rules, they're written in a domain-specific language that allow you to express how you produce your artifacts and so on. Yeah, it's entirely language agnostic. I already said this. So what is Buck2 for us? We have a large code base. And for us, using Buck2, migrating from a, let's say, community-driven build system to one for large code bases, it's orders of magnitude faster. And I will come to this. I will pick this up on the next slide. It has built-in incrementality and modularity. It has a built-in scripting language and query system that allows you to easily integrate it with any type of other tools. It's very easy to extend because all the rules are written in Starlark, so you can just add new rules that seamlessly integrate with the existing ones. And it comes with language interoperability for free. So now I said it's orders of magnitude faster than Rebirth 3. How can we achieve this? Well, if you want to make something faster, there are like three ways of doing this. Like you do it less often. If you still need to do it, you do less of it. And then if you have your kind of set of work, you make sure that you do it as fast as possible. I think that a lot of effort usually spent on doing it faster, but like just skipping the whole work when you can is usually gives you a larger benefit. So doing it less often, we have a global cache. For user remote execution, every build contributes to this cache. If you have a large repository, usually you don't change all the files at once and check them in, so you change like a small part. And for the rest of your build, usually everything is cached, you just download the artifacts. Doing it less, we have incrementality for every single action, so every rule or build rule that you express has this notion of incrementality. So you only need to redo it if one of the inputs change, and if you structure your rules correctly, you minimize the amount of work that you need to do when you need to have a change. And finally, doing it faster. There are two ways we have to achieve this. First of all, is remote execution. You have a significantly increased parallelism because that is way more than you could ever possibly try to achieve on a local machine through remote execution. So for large builds, if your build is parallelizable, which for Erlang it really is, you just do most of the thing in parallel and you get to a result much quicker. And for smaller builds, we have something that we call hybrid execution. So we will raise remote execution against a local execution of the same thing. Builds are hermetic, the result is the same. Whatever arrives faster, quicker, gives you the result. So we have really quick iteration cycles for incremental builds locally, for small ones, and comparatively really fast build times for larger builds. And like Buck2 loves Erlang, or Erlang loves Buck2. Luckily, the language Erlang is really capable, or our integration is really capable of making use of all the tools that Buck2 has to offer to increase build times, not increase, but to reduce build times and really create a good user experience. If you want to try it out, I encourage you, there's an example repository that you can just download. There's a README steps that kind of instruct you how to get the Buck2 binary. Download it and you can start playing around. It's a minimal example of a Buck2 repository. It doesn't come with remote execution or anything, it's just local builds. But if you choose to do an integration, it gives you a good starting point. I will just talk about a few aspects of how our rules are built and how it will look like. So it's like, I encourage a discussion afterwards. If you're very interested, please come to me. I'm happy to talk with you. So this is like essentially our basic building block. It's an Erlang application. Everything needs to be explicitly defined with Buck2. All the inputs need to be listed. But we have convenience patterns like you can use globbing and so on. And then you can define your dependencies and so on for applications. If you squint your eyes a little bit, that looks quite similar to like one of the Erlang manifest files, the app.ssc files that Buck2 uses. And really, it's used in a similar way. You use this information during the build process to first of all, define and track your dependencies, but also to generate the .app file that is part of the application. The difference here is that we have explicit paths from where the dependency comes from. So the dependency to the application utils, in this case, is explicitly defined with a path from the repository root or from the project root, which you know frees you from the need to do like any kind of big exploration. We have other rules as well. So these are essentially, let's say, cover your basic needs of Erlang build. That is what we needed. That is what we used, really. We have e-scripts, releases. We have lots and lots of tests. And then we also have a bunch of parse transforms. But all of this is extendable, either through contributing to the open source project, or if you choose to have your own project, you can seamlessly extend those rules with your custom rules. It comes with built-in interoperability with languages, and I think this slide I just wanted to kind of amplify that how modular and composable the build system really is. So let's say you have an application. Your application or your service uses a NIF for, I don't know, some type of optimization. You can write it as a C++ library target that generates you your shared library for the NIF, and seamlessly use it as a dependency, as a resource dependency for an application, which would then, in one build the library and place it in the priv folder of your application. So you can just have essentially everything in one system. You don't need to special code any case to make this happen, because, well, the NIF is not Erlang, it's another language. And you can just combine Erlang with Erlang itself. Let's say you have an e-script and you want to write an end-to-end test. You just take the e-script target, put it in the resource dependency of a test, and then it ends up in the data folder where you can call the e-script, check that your command line arguments are correctly passed, and so on and so on. So it's really easy to compose targets from even multiple languages. Then no restrictions. It's language agnostic in that sense. So how well does it work? As a reminder, we have thousands of Erlang files. We have millions of lines of codes and all of this other stuff. If we build the entire repository, currently it takes, if everything is cached, like I check out master and I assume we have built this at some point, it takes 2 minutes to build everything. And that means all the releases, all the e-scripts, all the containers, like everything. Uncached, it takes 3.5 minutes, so like not quite twice the time. But it's still, I mean, this is a case we never encountered, to be honest. This is like, since there's rarely a change that changes everything at once, and even if it does, you at some point, you make a pull request where CI will build this and populate the cache, so the next person still just has like an incremental build. And small incremental changes, they're like a second. It really depends on what you change. If you change a header file that, every module in your project includes, and of course that's not a second, but if you just change like a small beam file, then that's really, really quick. To have an unfair comparison with Reaper 3, because it's not really built to do this kind of work. And just building the application that takes over 15 minutes on like a really powerful machine with 24 cores. Yeah. All right. Setting up a project with Buck2. Again, a disclaimer. It's a let's say build tool for industry needs. If you have a small code base, it doesn't necessarily make sense to go through the process of setting up all the tooling required to use Buck2 in your repository. So if you have a large monorepo code base, multiple languages, and also if you have access to some type of remote execution that is usually requires paying for something, then this is a good use case for you. What you need to do, you have to get the build tool. You can get the standard library. There's also the build tool itself. Buck2 can initialize this for your repository as well. You have to get some setup for remote execution. There are examples for everything online, so look this up. If you want to use it for an Erlang project, there's an example repository that sets up a minimal tool chain and everything so that you can use it. And then you need some, project-specific configuration. All right, and then there's a demo. So the demo is really just using the example repository, which has an application with 2 tests and 1 beam file, so it's not really impressive. Yeah, I mean, what you do, we can build everything. Now, this will build a bunch of stuff, because it builds the entire framework.
If you can increase something.
I mean, yeah, how do I do this? Command.
Yes.
Let's build again. Everything is built. That's surprising. And we can test. There are 2 tests. With, so the testing is more rough around the edges. We have like a drop-in test runner currently. If you want to use this, you would probably want to supply your own test runner to integrate it, or you can use this. There's a very creatively named test suite, fail suite that fails, and and one that passes. Yeah, that's essentially it. There's integration for shell. So if you want to have so here's the application. What is it called? So you can run an Erlang target as well. It opens the shell, everything is loaded. So we made sure to support iterative development as well. You can recompile stuff in the shell, which will use the Buck2 to build this. So there's a lot of convenience tooling around it that we try to include in the open source release. There's an interactive test runner as well that allows you to iterate on tests quickly and so on. But yeah, I'm happy to show more, but I think I would like to thank you for attending and listening to my talk. And if you have if you have any questions, I'm happy to talk to you, or after the conference as well. Not conference, the talk.
Can you run this tool without internet access?
Yeah, I don't need a micro. Yes, you can. So you can, but then of course you don't have access to remote execution. The build rules, as they are currently written, they're heavily optimized for remote execution. So they do more things and maybe more complicated than you would want to do this. So you actually will get like a slower experience. Iteratively, it will still be fast, but the rules itself, they're optimized for good cacheability, good fine-grained builds and so on.
More questions? How extensible is it? Do I need to hack Rust code to add some new features or some scripting language?
That's an excellent question. So with Buck2, most of the core rules, they were written in Java and they were part of the tool itself. So if you want to add more core rules, you would need to change the build tool, which really is not what you want to do. The tool itself doesn't encode any language rules. All of those rules, they're written in Starlark. They are in the repository that you use them, either through pulling in a Git submodule for the standard library, or you can just write your own. So, for example, what we have, we have more rules than just the Erlang rules that we use in our repository as well. So you can completely customize this, extend it as well. There's also an integration layer for other tools. So quite often you need to get information out of the build system for other tools to process it in some way. There's a scripting language which is fully documented, and there is a query interface where you can get information out of this as well.
Hi. Can you go back to the shell where you showed the compilation? I saw some things that were not familiar to me. What was the build ID and the path there?
So every single build can produce metrics and is uniquely identified by a build ID. So I'm not really sure how well this is integrated in the open source release, but you essentially can, if you have a problem with a build, you just say, hey, I have a problem with this build ID, send it to me over chat or email or whatever. And then we have some.
It's in your own OTP, or?
The build ID is what Buck outputs. It says like this build identifiable by this build ID.
No, I mean in the Erlang shell when you do compile the file.
Yeah. So if you compile the file, so in this case, Beam artifacts are hermetic. So we delegate building back to the build system. So we don't try to re-implement the build process or try to discover how a file was built out of the information that is in the Beam, but we essentially query the build system to rebuild this Beam file for us.
Okay, and the last question, what about cross-compilation? Do you have support for that?
It is somehow supported, like you mean compiling for other languages, for other platforms.
Other platforms, yeah.
Yeah. So for you can do it. It's essentially part of the setup of your tool chain. So there's a big configuration system in there that allows you to specify how things are built and how to switch tool chains. And a tool chain, just to clarify, is like the set of build tools that you use to execute your build and flex as well. So if you want to use a different type of compiler, you would kind of encode this in the tool chain. But this is then getting more and more involved in how to configure your system.
Thank you.
But it's possible.
Do you have something corresponding to configure autoconf stuff?
It's something that we. Do you mean reading whatever the environment is?
Yeah. Adapting to different operating systems and C compilers and
you can
libraries.
So you can build this. The idea here is that everything needs to be encoded within the repository or the project, but you can encode this in different build configurations. It's generally not like you pulling in information or things from the environment, from your build machine, is quite discouraged in this model because builds are supposed to be hermetic. Like your compiler is essentially input to the build process and needs to be encoded for for the build process as well. But when you do this, then you can build for different platforms and so on. So I would say yes and no. It's a different system. It's a different way of using builds, or of a different way of building, because you don't try to discover what you have on your current machine. You encode. You have to have it encoded as part of the build process explicitly.
Maybe you talked about this and I missed, just to double check. So if I have a large Erlang application with a bunch of dependencies like other Erlang libraries, and they are built with Erlang MK, Rebars 3, like whatever, how much benefits will I get with using this build system? So will it be, I guess it will be invoking whatever build toolchain is configured for that library, right? Or will it be able to leverage, like translate it to the Buck2 language to build those libraries?
So the question, I understand, is how do you integrate third-party libraries? With one exception, we vendor them into our repository and just write a bug target. There, it's usually like a standard, like as more standard as Erlang libraries are. It's very easy to write a target for them, and then express your dependencies. It is possible to hook Rebars 3 or something like this into as well. We had this at some point, but we removed this integration entirely because it was just not necessary. We didn't see any advantage after a while anymore.
I think we're out of time in this case. But if you have any other questions, I guess you welcome them offline.
Yeah, exactly. So if you have any questions, please find me during the breaks or so. I'm happy to talk with you.